Okie dokie. Right, here we go. This is part two of the intervention for linear graphs. Okay, the first part dealt with how to find equations of a straight line, dealt with gradient of a straight line, and dealt with how to find our y-intercepts as well. What this video is going to look into is it's going to look into how we deal with perpendicular lines. It's going to deal with tangents to a another line. We're going to look more in depth at how we deal with those harder questions that can push us up to grade 6, grade 7, and possibly onwards. Okay. So are you going to, before you do this stuff, you're going to have to know what you're doing with the previous stuff. So that's knowing that a gradient, we do change in y divided by change in x. We can use coordinates to find y-intercepts, or we can look at a graph to find a y-intercept. Okay? So the first thing that we're going to look at here for this video is thinking about a perpendicular gradient. Okay, and if you take a look at the two lines that I've got there on the left, you can see that these two lines are perpendicular. They are at right angles to one another. Okay, now this black line, if we check this out, we can see that it's got a gradient of 1. For every one step across, we go one step up. This gradient is 1. And if I look at this, I can see that this one has got a gradient of -1. For every one step across, I have to come down by 1. So from looking at this, you might think, well, okay, perpendicular lines are negative versions of one another. But you would be wrong. Okay, if you check out this line here, this line has got a gradient of, what is it? 1, 2, 3, 4, 5, 6, 7, 8. So this gradient is 8 divided by 1, 2, 3, 4, 5. 8 over 5, which is 1.4. A line that would be perpendicular to this wouldn't have a gradient of -1.4, because if it did, it would come down a bit like this. And we can see, although it forms a nice X shape, it's not perpendicular. Okay, that's an acute angle there. This is not perpendicular. Okay, so it's slightly more than that. And I believe I mentioned it in the part 1 video, that perpendicular gradients are negative reciprocals. Okay, so what this would mean is that I would have a gradient which goes, instead of 8 steps up and 5 steps across, they would have to swap over and become the negative version of it. So this one here would become 5/8 from doing the reciprocal, but it would become -5/8 from making it also negative. If we do that, then we get these two lines appearing at right angles. Okay. So perpendicular gradients are negative reciprocals. So perpendicular gradients, negative reciprocals. Okay, and if you remember that word reciprocal, it's where we take a fraction and we just flip it over. Okay, that's a word that we have used before. Especially when dealing with negative powers, that involves us doing reciprocals. Okay, so that is perpendicular gradients. They are negative reciprocals of one another. Okay, And that's another good argument for us to be having our gradients written as fractions or whole numbers. Okay, I don't really want to be doing reciprocals of decimals because it just involves more work. Okay, reciprocals of fractions, nice and easy. We just flip it upside down. So where does that take us now? Well, what we could have, if we're taking a very similar example to last time, is we could have a gradient or a line connecting 2 points, and we might want to find the gradient that is perpendicular to it. So if you remember from the part 1 video, if you watched that, we're thinking how much we've gone up divided by how much we've gone across. And hopefully you remember that we've got our x and y parts as before. For our ups, we've gone from 5 to 11, which is going up by 6. And our cross, we've gone from 2 to 5, which is going across by 3. And our change in y divided by change in x tells us that our gradient should be 2. The gradient for that line is 2. If we're finding the perpendicular gradient, we now need to find the negative reciprocal of 2. Reciprocal of 2. Now, we need to make it negative, so negative something. You can always imagine that would be 2 over 1. So the reciprocal would become 1 over 2. So the negative reciprocal of 2 would be negative 1/2. And if you were trying to write this as an equation of a straight line, we would be able to write y equals negative 1/2 of x plus c. Or if you wanted to tidy it up a little bit more, you could write negative x over 2 plus c. Okay, and if you're not sure where that has come from with that bit I've just written here, then you need to go back and watch part 1. If you already had watched part 1, then that's our equation of a straight line. You need to be able to remember that. Okay, so that would be us finding a perpendicular gradient, which, it's very nice. It does the business. And I will admit, the use cases of this within the GCSE remit are relatively small. We will normally ask for an equation of a line which is perpendicular to one that we've been given. We might ask for you to say, are these two lines perpendicular? So you're going to need to check their gradients. Or we might just ask something a bit more like some of these. Okay. Now I'm going to give you a moment now to pause the video as it is, and I would like you to see what you can do of these two questions. If you want to try the first one first and then unpause, I will go through the first one and then I'll go through the second one shortly afterwards, okay? But you can pause this video at any point and try out some of the questions, and you can see how you do. You can see that both these questions are only worth 3 marks, but they're 3 marks that you'll see you don't have to do an awful lot for them, okay? So, I'm going to give you 5 seconds to pause the video. Okay, so hopefully you've had a go at that first question, question 17 for us here. We've been told that a straight line K has an equation y equals 2x minus 5. And we've told that the straight line J is perpendicular to line K, passes through the point negative 4, 8. And we want to find the equation of the perpendicular line. Well, the perpendicular gradient is going to be the negative reciprocal of the normal gradient. Okay? So if our normal gradient is 2, I want the negative reciprocal of 2. Okay, well, we saw we can write it as 2 over 1, which reciprocates to 1 over 2, which then becomes negative 1 over 2. And just like in our previous little section, we can now write y equals negative a half of x plus c. Now, if you got up to that point, that is probably going to get you 1 or 2, probably 1 mark for finding the negative reciprocal gradient. For our next little bit, what we're going to have to do is use the coordinate that we've been given, just like we would have done in those part 1 questions that we were looking at before. So I'm going to use negative 4, 8. X is negative 4, y is equal to 8. So 8 is equal to half of negative 4 would be negative 2. Negative a half of negative 4 is going to be positive 2 plus some number. And again, this said it in part 1. It doesn't take a genius at this point to realise that c should be equal to 6. Okay, because we can take 2 off of both sides. That means my equation for my line j would be y is equal to negative a half of x plus 6. And if you want to write the x on top of the 2, that's fine as well. And where would I say the marks would come from? I would probably say 1 for that, 1 for that, and 1 for that. It's raining outside. Anyway, this is your chance to pause the video for the second one to give the second one a go. I'll give you 5 seconds again. Okay, so here we go. This time we've got a straight line L is perpendicular to the equation y equals 2x plus 3. And the line L passes through the point 10, 3. Find the equation of the straight line L. Okay, and just like we did before, if it's perpendicular to this line, I need to find the perpendicular gradient. I've just realised I've not explained what this means. This is my shorthand for perpendicular. You can see you've just got 2 lines that are at a right angle, so they are perpendicular. And again, we've got 2, which is the same as 2 over 1, which reciprocates to a half, which then the negative reciprocal would be negative a half again. So that means, again, our equation will be y equals negative a half of x plus c. But this time we've got a different coordinate. We've got 10, 3. Okay, and I've got a feeling this is going to end up with some fractions. So here we go. 10 is our x value. Oh, excuse me. Y is our 3. And I've changed my mind. I don't think this is going to involve fractions. So 3 equals half of 10 would be 5. Negative a half of 10 is negative 5 plus c. Now, add on 5 to both sides. We get 8 is equal to c. And our equation is y equals negative a half of x plus 8. And there we go. And I would say that the marks pretty much go in exactly the same places. 1 for your perpendicular gradient, 1 for your value of c, and 1 for the final answer. And you can see these are pretty nice. And I would say that this is, you know, a very staple grade 6, kind of maybe pushing towards the boundaries of 7, maybe. Okay. But with this part 2, I wanted to kind of push to show, you know, what is the worst case scenario. This is a decent scenario, and I would be very happy for people to be picking up marks on these. But I want to show you, where does this go? You know, if you're one of those people considering AS Maths, this is perhaps something that you may need to look at a little bit more in the future. Okay, so suddenly things just got a whole lot different. Okay, and it's, the title says, this is taking it to an extreme level at GCSE, but it's not impossible. Okay, right, our goal is to find the equation of the tangent. Okay, that is our goal. Find the equation of the tangent. Okay. Now, whenever I'm looking at any kind of like algebraic graphy problem like this, be it at GCSE or at A-level, I always look at what have I got. Okay, and the irritating thing for this, and I'm like, is because there's no grid. I have no idea what this number here is going to be, and it doesn't cross my x-axis either, so I've got no idea what this number is going to be either. What I do have is this line that's been called f. Okay, now I'm going to need to use this, and I've got this point here, 3, -4. Okay, I'm going to need to use that to my advantage. I'm going to need to know all sorts of stuff about this. Okay, so what I'm going to do is I'm going to give you a chance to pause. Okay, and I am then going to drop some hints, and then I'm going to give you another chance to pause, and then I'm going to go through the problem. Okay, so 5 seconds to pause starts now. Okay, so now is where I'm going to drop some hints, just in case you are crazy stuck. So my first hint is, can you work out what the gradient of f is? Okay. If I know what the gradient of f is, can I work out what the gradient of the tangent is? And then my third hint, use A as your coordinate. Okay, that should get you through the problem. Okay, so I'm going to give you now another chance to pause. So you got 5 seconds. Okay, now I'm going to go through the problem. So I said the first thing to look at here would be the gradient of f. Okay, that's this line here. Now, we are going down by 4, so -4, and we're going across by 3. So my gradient of f, which I'm going to put mf, gradient of f, is -4/3. Not amazing, but, you know, it'll do. So that was part 1. Part 2, can we find the gradient of the tangent? Well, this is a radius of that circle. The tangent is at right angles to that radius. So the gradient of the tangent would be, I take my gradient of the radius, reciprocate it, and change it from a negative to a positive. We change the sign. So my gradient of the tangent, I'm going to put m tan, is 3/4. Now, if we know the gradient of the tangent, just like in our previous problems, we can now write y is equal to 3/4 of x plus c. I now, looking at my third hint, use A as a coordinate. So the 3 is my x, negative 4 is my y. I have got negative 4 is equal to 3/4 of 3 plus c. Now this is... ugh. Okay, negative 4. Let's tidy it up a little bit. That would be 9/4. 3 times 3 is 9. I'm going to have to take off 9/4 from both sides. Now, 4 would be the same as 16. 16/4. So I'm doing 16/4, take away 9/4, which is 7/4. Ooh, which is equal to c. So the equation of my tangent is y equals 3/4 of x plus 7/4. Oh, sorry, no, it's not. I've been an idiot. My apologies. That 4 should have been negative 16/4. If I do negative 16/4, take away another 9, that's going to get me to negative 25/4. Almost made an error there. Well, I didn't almost. I did make an error. Now that makes more sense. If I had 7/4, which is what I was going to say, that would have been up here. But my y-intercept definitely is not up there. My y-intercept is definitely down there. Now 25 divided by 4 would be 6.25. So negative 6.25, that does look pretty good for where that tangent crosses the y-axis. And as I say, that is a scenario where is something quite extreme, but is certainly something that will test the higher grade boundaries for sure. You know, definitely going further than a 6. Definitely. This I would say that this is going to challenge your 8s, 9s. Okay, this is a very typical kind of AS maths kind of problem. Okay, so this would be challenging with those much higher GCSE grades. In terms of linear graphs, I'm going to stop there. However, I am just going to do a few more random things that if you've got to this point in the video, you're probably going to be wanting to hear about as well. Okay? And I'm going to do these on purple just because they are extra bits. Other things that we could think about here. You've got a triangle here. I might want to know about the area for that triangle. Okay, now we might be able to find out where it crosses the x-axis if it just gives us a little bit more of the picture. So I would have a hypotenuse, I'd have an opposite or an adjacent side, which means I'd be able to find the base, and I can do base times height divided by 2. Or I could work out this angle here and use half AB sine C. Another thing that I might want to do, I might want to know what the equation of the circle is. Now, if you remember from when we looked at circles, we said that circles were essentially Pythagoras' theorem. So x squared plus y squared is equal to the radius squared. That might be something else that we would be asked about with this scenario. What else? Circles. I mean, it always links into circle theorems. So we used a really basic one here, which is that a tangent and a radius meet at right angles. But we could have further angle problems in here, and we might need to work out, like, that angle there. You see, we can draw a little right-angled triangle there. Okay? And it's bearing in mind all of these different things which we have learned how to do over the last 3 years that we can put together. So you've got trigonometry, we've got area, we've got equations, we've got gradients, all of this that could be contained within this question. Okay? And the more that you can look at something and go, right, circle equation, I know that. Area of a triangle, I know that. Tangents, gradients, perpendiculars, all of this kind of stuff. If you can remember what each of these bits are, just means when you come to look at an extreme problem like this, you can just kind of break it down into those smaller parts, okay, and deal with one step at a time. What can I find out? Well, I can find out this. Okay. Anyway, I'm going to leave that video there, and I will see you in the next one. Bye-bye.